what I can observe, right, is factual, right?
No, I was joking because that's what you guys say. I look at something in the sky and we know what it is. So
Oh,
of
okay.
course,
All right.
of course.
Okay. Yeah, so I like the idea that the Earth is not flat. I'm not going to argue for anything else. That I'm just going to argue that the Earth is not flat, right? Which is fine. My problem comes up is that y'all, right, can't seem to agree upon your own rules. And anytime we ask for evidence, right, to have a nice, civil, intellectual discussion, you always take the position, I don't have to prove a negative, right? Which just shows me that you don't have the evidence, or you claim that I have to go do the research. Where everyone in here can just slap thousands of papers to support our claims, and you simply just say, oh, they're lying. So it just makes you sound just like a numpty.
Yeah, of course. I mean, if you just try to provide a paper, I think, most flat earthers will just say that's nonsense. But if you have the experiment to go with that paper, then I think you'll find most flat earthers will take a look at that for sure.
Papers describe experiments, Chemo. That's what papers do. They describe experiments. They are the data. They are the proof that the experiment occurs. This is how the enterprise of science gets done. You don't dismiss papers. They are the gold standard of scientific evidence.
This is where we question, like I say, your method, because when we do get into the ins and outs of how you go about
the thing that's brought us sort of 300 years of prosperity. Is that what you're doing? You're questioning the scientific method.
No, so
they don't follow the science. They don't follow the scientific method. We went over this yesterday. You guys have no science.
Yeah, we do.
So of course you say you have data. I think that's where you think again that you have the experiment to go with the paper. So in your mind, when you say like a paper,
papers are written from experiments. The paper doesn't come first. The experiment comes first.
That's my point. That's my point. Like you're saying here now, you're saying, well, of course, there's an experiment. Absolutely. So when we say to Dr. Smoothbrain here, where is the experiment with your paper? Kind of breaks down at this moment, and that's why with Babs earlier on, the discussion.
All right, Keeman, let's do that, right? I've heard you enough times. I want your definition of what you consider evidence.
Okay, so if we're looking for evidence of a claim, you're going to have to test that, especially if it's in the natural and physical world, where using the scientific method. Now, the only way we're going to accept your answer, your conclusion, is if you, the person, were to manipulate the independent variable to for the cause to the effect.
He asked you.
That's the only way.
He asked you what your definition of evidence is.
From now on, I don't wish to talk to you because you're useless. Because you're saying that because I can't be God and alter volcanoes. Volcanoes aren't real.
No. What we're saying is that that's not science, is it? I mean, if you have an observed phenomenon and you want to know what the cause is, you would just test it, right?
Chemo.
How do you test a volcano, buddy? That's a naturally observed phenomenon.
Well, what causes it?
It's the movement and the crust beneath. It's, I don't know the exact. I don't know the exact causes, but from what I understand,
but rest assured, if you went through the method, you would know the cause because you would predict the cause, you would test it, and you would have a conclusion.
No.
Okay, perfect.
Under the scientific method, you would have a hypothesis.
Absolutely, your hypothesis is your predicted cause.
Do volcanoes exist?
No, that's
you would have a hypothesis. You would have a hypothesis that would explain why volcanoes erupt, right?
No, again, we're looking for why the volcano erupted. So you're saying
that would be the hypothesis, yes.
Yeah, so you're predicting the cause of this. So you'd have to test.
No, you're not predicting it. I'm sorry. Go ahead, Leo.
I'm going to detract a little bit. You flat earthers who reject mathematical formulas, what in this picture that I just posted, what does that look like?
See, that's just a language describing something, Chris.
Yeah, guess where this is at? This is in Michelson and Morley's experiment. They use mathematics to formulate and describe what they were trying to find.
Mm-hmm.
So So you guys who reject math,
But look, let's go back to Dr. Smoothbrain's confusion about.
no, we're talking about Michelson and Morley using mathematical formulas to describe the ether and what they were
hot mic, by the way.
The ether, and guess what? If you're going to reject mathematical formulas, you have to reject the ether because Michelson and Morley were using math to show how
Jeremy, I think you got a hot mic.
Oh, I'm sorry. Hold on. Don't mute me. I'll mute.
Oh,
Oh, my bad.
it's all right. Yeah. So this is what we expect anyway, Dr. Smoothbrain. Like your capitulation, because you're realizing. Well, like you just said, I'm not God. I can't manipulate these independent variables, which is why we advise you not to make these claims. Just go with what can be tested, and just be clear on the fact that you assume this is what happened. If it's an assumption, without any.
That's not how science works, Chemo. Science works by observation.
I don't know.
You ask a question.
Jeremy. You muted Jeremy.
I'm sorry.
What's going on? Someone's muted Jeremy.
I don't care. Science doesn't work that way, Chemo. It works by you make an observation, you ask a question, you form a hypothesis, and then you design an experiment to test the hypothesis.
You were muted, Jeremy, right? But yeah, I mean, Brendan, that's pretty much you're right. Yeah, so whatever you think in the natural and physical world supports your heliocentric model, you don't have an experiment for that. So, for example, let's take.
What is the heliocentric model?
For example, hold on, Brenda. Let's take example: Earth turn, Earth spin, rotation. So you've got a device which you say tells you the Earth is spinning, like the pendulum. You know, you say, "Bob, thanks, Bob," that thing. So, in order to know if this was scientifically valid, we would have to manipulate the Earth turn to show that this is the cause of Bob's machine. That it's given us the measurements that it is.
Or, like the volcano, we can just observe the fact that it does it, and then we can ask why. So that's the problem with Chemo is we've kind of moved a step beyond that because we have objects in space looking at the Earth, and we can observe the turning of the Earth. So that's something we've done for quite a while. So we've now moved the Earth rotating to the same position as a volcano. We observe a volcano. Why do they happen? We've observed the Earth turning. Great. Why does it happen? So we're now a step further down the road.
Did Brenda say she had some science or some globe science? Let's hear it.
She understands the method very well. But I'm just saying here to Dr. Smoothbrain. Well, I hear Antidrus here. I
provided science. I provided
here also. Like I said,
let's hear some globe science. Anyone? Let's go.
I provided
their
science.
quote would be.
Michelson and Morley's gyroscope to show ether.
So the gyroscope is supposed to show Earth turn, but we've got to show that the Earth turn caused the gyroscope to rotate. And the only way to do that, obviously, would be to manipulate Earth turn, which is obviously something we can't do. So we just have to infer that the Earth is turning.
You can put the gyroscope on different spots on the Earth, and it will change the way it moves if the Earth was a sphere or if it wasn't a sphere. So that's your independent variable that you can manipulate. Job done. The end.
Well, the independent variable is the cause. Yeah.
You can manipulate a variable and you can make predictions and you can see whether those predictions are matched by your hypothesis. And if the predictions do match your observation, then you've confirmed your hypothesis. That is how science gets done.
Yeah, but we know that the independent variable is the cause to our dependent.
I don't care about your independent variable and your cause. That's your high school understanding of science. I'm a scientist, and the way science gets done is, like I just said, you make a hypothesis based on and then you devise some measurements or an experiment that you might think you'll have certain observations if the hypothesis is true, and then you go out into the world and you observe whether it matches your hypothesis. That's how science gets done. I don't know whether there's an independent variable or a cause there. That's not really relevant. Only in your high school version of the scientific method is it relevant.
Let's hear your some globe science. Go. Natural observed phenomena.
Okay. So,
Let Brenda do it.
yeah, I have an egg suspended in a glass of water.
What's your natural observed phenomena?
Yes, the egg is suspended in the glass of water.
Egg suspended in water?
Yeah.
What's happening? The egg's just sitting there doing nothing?
It's sitting there doing nothing. It's midway.
That's not a phenomena.
Yeah, it is.
Yeah, it is.
You're
But how did
already
that happen?
wrong.
Okay, so you've got the egg in water, Brenda. So what?
Nothing's happening. Chemo, in order for it to be a phenomena, something has to be happening.
No. So look, we can say we've got the egg in the lake and it's floating, and you're like, well, how is that happening? Because before the egg, it sank. See? So now we have to explain how does that happen? Why is it not going down? So Brenda, carry on.
Excuse me. This is my experiment. So
Go ahead, carry on.
I have a tall glass of water. The egg is suspended halfway between the top of the water and the bottom, and it's just sitting there. And that is a phenomenon.
Okay, your egg suspended in water is your phenomenon.
Yeah, yes, it is.
It can happen in nature, Jeremy. Yes. So go on.
All right.
And so then I have a hypothesis.
What's the cause? Why? How is it doing that? What caused it to sit in the middle of the water?
I'm not at the cause phase. I'm just asking questions of the world. That's what a hypothesis is, and I want to know. I suspect that the reason it's in there is because the buoyant force is exactly equal, enough to suspend it midway in that column of water.
So what's the cause?
So now hold on. So what? So what, Brenda? What caused the egg to
No.
What caused it to stay there? Yeah, we don't care about what you think about all of that. We want to know what caused it to stay in the middle like that.
That's what I just said. I just told you the buoyant force.
So buoyancy caused it to stay where it is.
I'd say
the buoyant force.
The buoyant force.
You're going to need to explain the buoyant force because we're looking for the cause.
I already know what the buoyant.
Maybe let Brenda finish a sentence. She can.
I already have that. I already have an idea of what the buoyant force is. I'm testing it. So I have this idea that the buoyant force is in equilibrium, places the egg in equilibrium there, and so what I need to do is change the buoyant force. That's my independent variable.
No, the buoyant force, you can manipulate it.
You need to explain you need to explain the buoyant. What is the buoyant force?
Oh, I already know what that is. I already know what
tell
that
me.
is.
You need to tell me. It needs to be in your hypothesis.
What's the mechanism for buoyant force?
The buoyant force is in equilibrium. So the pressure of the surrounding...
What's the mechanism to cause a pressure, to cause a force?
The buoyant force is in equilibrium. It is the pressure of the water around it is in equilibrium with gravity.
Ooh. So the pressure, your hypothesis is the pressure?
No, my hypothesis is the buoyant force is in equilibrium with gravity suspending the egg in the water. And so my independent variable...
So space-time.
No
you
space-time.
Realize you have space-time bending in your hypothesis.
No space-time. This is elementary high school physics. And so then my independent variable would be the buoyant force, which I would alter.
No, I think, Brenda, you've got a string holding that egg up in the middle of. So you've got to divide.
That's
no way you can suspend an egg.
I don't. And the reviewers, when they review my experimental setup, they will decide whether or not there's a spring or not. But for now, I'm going to vary. I'm going to vary the buoyant force by changing the density of the surrounding medium.
Yeah, but what is the buoyant force? What is it?
I already know what that is. I already know what that is. I'm testing it.
Tell us.
What, you
don't know? Tell us
what
the buoyant force is. This needs to be in your hypothesis.
I already know what the buoyant force is.
What are you trying to prove? What are you trying to prove with this here?
I'm trying to prove the egg flows in the middle.
I'm trying to prove that if I alter the buoyant force, the position of the egg will move.
So you're going to just change the medium that the egg's in?
I'm going to alter the buoyant force.
By changing the medium, yeah. You're going to do Riley's egg experiment? Is that what you're trying to do?
Well, I'm
you're
going to
already
alter.
You're going to make the medium more dense, Brenda. Yeah.
This is relative density.
Well, I might make it less dense. I'm going to pour.
So you've just discovered that. So what we've discovered that when you add salt or change the density, it moves the egg.
I'm not going to add salt. I'm not going to add salt. The water's already salty. I'm going to add fresh water.
Yeah.
All right.
What's the
change
prediction?
the density then.
What's the prediction, Chemo?
So you're going to control. You're going to control the up or down movement by changing the medium.
What's the prediction? What's the prediction?
That's what we do. This is our thing.
So what's the prediction?
So hold on. Look, Brenda, slow down. So you've got water in the cup. You're going to pour more water in. What do you think is going to happen? It's going to flow over, right? So you're going to change the medium out. You're going to take out the salt.
I'm going to
remove some of the salt that was already in there. It's going to pour out. You're going to put fresh water in.
The water is already. I'm going to make the surrounding medium less dense.
Less dense, yeah.
Yeah. So
again,
what's the prediction?
Well
Chemo?
done.
What's the prediction?
You've done it.
We need to make a prediction before we do the experiment.
Your predicted cause is the density. That's what you did. You changed it.
Not my.
And that's what we saw.
No, I'm going to alter the buoyant force by changing the density, and I'm going to make it less dense by pouring fresh water in there because the water's already salty.
You're being silly.
Chemo's trying to avoid answering the question because he's so stupid he doesn't know what the answer is. He understands buoyancy so poorly he doesn't know what the answer is going to be, what the prediction is.
The egg's going to go down.
Congratulations. What was the cause?
This is our experiment, though. Right. You just proved relative density.
No, but what was the cause? What was the cause? What was the cause of the egg going down?
This is so silly.
We changed the relative density.
I changed the buoyant force.
No, you changed the medium, the relative density between the two. You just did.
You changed the size of the object, Brenda.
I didn't change the size of the object. I changed the density of the water.
Right. So how did you change the buoyant force then? This so-called buoyant force.
I changed the buoyant force.
But the egg is already under buoyancy. Yeah. Buoyant.
Yes, it's in equilibrium.
Yeah, exactly. So you're trying to move the egg up or down.
Yes.
How are you going to add or take away buoyancy?
By adding fresh water to it, I'm going to lower the density of the water.
Yeah, but fresh water is not buoyancy, Brenda.
Chemo just reveals how dumb he is. He doesn't even understand the concept of buoyancy. He doesn't know how it works. Well done.
Hey,
exposed.
Tony, are you there? PhD Tony?
This is ridiculous.
Yes, I'm here.
Around to something here.
This is nonsense. Brenda always takes us down the realms of stupidity.
What's wrong? What did I do
Brenda,
wrong?
can I say something? One quick thing. Chemo, I don't know why you're arguing against this. Every major navy who has a submarine does this. Instead of changing the density of the water, they change the buoyancy of the submarine by pumping water in and out of the vehicle.
Yeah. We understand. This is relative density. This is our thing.
No, it's not relative density at all, Jeremy. You cannot describe how a submarine or the egg in Brenda's experiment stays suspended in the medium by only using relative density.
We can manipulate.
Relative density is not a force, Jeremy.
In the submarine, all you're doing is filling the chambers with water and removing the water.
And what does that do, Chemo?
What do you mean, what does it do? It makes it go up or down. You change the density.
How? No. How do you, if you only pump in 1,000 liters, if you pump in 1,000 liters of water versus 500 liters of water, how do you control how fast it ascends or descends in the water? You can't do that with relative density.
You've got to
make. Your claim is bullshit.
You
cannot describe the dynamics of what happens in that scenario by using relative density. It's impossible.
You've got to make the submarine lighter or heavier.
You're talking words, and you know what? Those apply.
How do you make
you cannot formulate any mathematics to actually design a control system. Because at the end of the day, that's what you need. You need a control system to be sure you know the submarine is going to behave a certain way and move a certain way. You cannot do this,
Yeah,
Chemo.
it's very
That's
simple.
true.
You got to change what the if it's
You're
light
not listening
or
to what I'm saying. Your words mean nothing until you can formulate it and show me that I can put it in a control system.
no mathematics
day.
won't tell you anything like that.
And Jeremy, you have nothing more to add to this except QE's rhetoric. This is all you've been doing for the past couple of days. Have you memorized his some of his speeches or something like that? Because I've noticed that about you the last few days. You're just parroting everything that he's been saying. You have no originality. You do not understand science one single bit.
That's a fallacy. You don't understand fallacy.
They're just upset because they've lost their globe, their gravity, their science.
You know, it's annoyingly frustrating listening to you spout the same shit day after day with nothing new to bring to the table.
You're a rocket scientist. Surely you have some science.
Can you
science
point?
I
work,
do,
no?
Chemo. I know how to design a control system. I know how to do dynamics. I know how to do physics. You can do none
You
of
don't
those.
have to- you go against physics if you think you can have a vacuum without a container.
Chemo.
That's not physics. Physics says you can't have gas pressure next to the vacuum. You can't have gas pressure.
No, physics doesn't say
It's
that.
a false dichotomy. It's a total misnomer.
Physics
That's
doesn't
not even
say
what
that.
the model is. Sorry, Brenda, go ahead.
Chemo.
You have no idea how
The flat earthers are claiming that my scientific experiment is not scientific. So could they point out the flaw, please?
Yeah, your shit is trash, Brenda. I'm sorry.
No. I want to know. I want to know how I would correct it. What would I do differently to correct for my your proposed errors in my experimental setup?
Well, in your hypothesis, you said the buoyant force, but then you went on to manipulate the medium that the water is in. So I don't know why you used buoyant force. You should have just used the correct hypothesis.
How do you calculate buoyancy?
We're not worried about calculate. We're worried about cause and effect.
We are. That's kind of the whole point. It really
Jeremy,
is.
you should calculate it, right, in order to estimate it.
Buoyancy requires gravity. So again, it's not that it's buoyant; it's relative density. That's what we're dealing with
it's
here.
not. Buoyancy is not relative density, but it does have to do with the density of the medium that the object is in. So what would I do differently in my experiment?
Buoyancy includes gravity.
I'm aware of that. We know that.
Besides your hypothesis being wrong, you did a great experiment that proved relative density.
How can a question be wrong?
No, you did a great experiment that proved relative density.
No. How can you said my hypothesis was wrong? How can a question be wrong?
Because you said buoyancy is the cause. Because you said buoyancy is the cause. You guessed
what's wrong?
It wasn't buoyancy. It wasn't buoyancy. It was the relative density in the mediums.
You don't know that.
And you proved that when you changed the medium.
You can't.
You proved it when you changed the medium.
No, you can't say that a question is wrong, and you can't say that buoyancy is not involved because I changed the independent variable, which was the buoyant force, and it caused the egg to move.
Which was the medium's density.
Yes.
So you changed the medium's density. I don't know why you used buoyant force.
Well, do you know how to calculate?
We're not worried about calculating shit.
That's
We're worried about cause and effect.
It's kind of the whole point.
We're worried about cause.
It's the whole point of the experiment.
The whole point
is calculating density.
Effect.
Will it sink or will it not?
Science is cause and effect. Not calculating shit. It's cause and effect.
Jeremy, you're spouting density. How do you think that value is determined?
I don't know. How is it determined?
Well, you know what? Let me ask you a simple question, Jeremy. What are the units of density? And then tell me what the units of relative density are.
It's the relative density is just the density of the object compared to the density of the medium it's in. That's all.
That's not what I asked you.
So it's unitless.
What's the units of density and what's the units of relative density?
Why don't you work it out?
Keeman, you know that I can. I'm not talking to you. Jeremy,
for what object? Question. For what object?
Why does Jerry need to work it out?
Water.
He doesn't need to work it out. He doesn't need a gotcha.
Keeman, I'm not talking to you.
I don't know how many grams per cubic centimeter water is.
I'm not asking you what the values are. I was asking how you come to that determination.
How do you know something's denser than another thing?
You're not.
No, he's asking for the unit of measurement.
Yes. What are the units of density?
Oh, the measurement units we use? Grams and cubic centimeters.
So, okay, so what's
Or
the
you
units
use
of relative
kilograms
density?
What?
What's the units of relative density?
It's the grams per cubic centimeter of the object.
Excellent.
Compared
Now,
to,
how do you take it from...
compared to, I wasn't done.
No, I'm not done. My question.
wasn't
He wasn't
How
done,
do you
Rocket
take
Science.
that
You asked the
and
question.
go to meters per
I wasn't
second
done.
Why are
squared?
you even asking questions if you won't let him finish?
Shut up, Chemo.
Seriously, you know what? Forget it. We're not going on.
How do you go
Yeah,
from
forget it,
relative
Jeremy.
density
Why
to
even answer me?
acceleration?
Why go on? I know.
Finish your point, Jeremy. Rocket, let him finish.
No, he hasn't. Now he hasn't finished the rest of my question.
Can't even finish
How do you
your
go from
sentence.
relative density to acceleration? That's the part you don't get, Jeremy.
I want to contest the flat earthers' objection to my experiment that it involves gravity. It does not involve gravity. I'm simply going by the Archimedes principle. I'm not including gravity in my experiment. Right? So Archimedes' principle. Then
Your experiment proved relative density.
No,
That's
no,
all
it
I
didn't.
did.
No, it didn't. It showed that the
That
buoyant.
shit was.
It showed. Let me explain it to you because you probably don't understand Archimedes. Archimedes said, basically that the magnitude of buoyancy on an object is equal. It's equal to the weight of the fluid it displaces, right? So my independent variable, then I change the weight of the fluid that is displaced by either adding salt or adding fresh water. That's the buoyant force. So I altered the buoyant force by changing one of the factors that affect buoyancy, which is the density of the fluid, the volume of the fluid displaced. That would have been another way to do it, or the local acceleration.
How do you control the direction then with your buoyancy force?
By making it either greater, more dense, or less dense. Because that, remember, this is Archimedes' principle.
Buoyancy. Change the buoyancy.
Archimedes.
You sure are saying density a lot.
Archimedes, yes, because that's part of Archimedes' principle.
And medium.
That the magnitude of buoyancy on an object is equal to the weight of the fluid it displaces. And so by changing its density,
with buoyancy.
So by changing the density of the fluid, I'm changing its weight.
Does that control the rate that things fall, the buoyancy?
The buoyancy force is a force opposite to gravity.
Does it control the rate things fall? Does it control that speed?
What are you talking about? No.
The acceleration, 9.8 meters per second, does buoyancy control that rate?
No.
Is it the cause of that rate?
Again, Archimedes' principle is that the buoyancy of an object is equal to the weight of the fluid displaces. Did you hear the word gravity?
Look, Brenda, that egg moved up at a particular rate.
Did I say the word gravity in there? Did I say the word gravity?
Does buoyancy control the rate of that object falling?
It isn't falling.
So I just want to state the major. Let me just state the major flaw in Brenda's whole experiment that she just tried to do. The first flaw was that in the beginning, when the egg is just in the beginning, when the egg was just sitting there, nothing happened. It's not somebody's talking all the way through me.
Boonan, being very disrespectful.
So the
first
floor
part of the experiment,
mopper
the
knows what's
natural
wrong with
observation.
a scientific experiment.
The first.
I'm sorry, I'm laughing at the.
What in the world is going on here?
I can't.
Oh, I'm destroying the flurfs. I'm destroying the flurfs.
They can't let me get this out because it's.
Can you help Rakia settle down? He's having a meltdown.
So now you're going to pipe up about me when that guy broke in 5 different times on purpose?
Yeah, you're the loudest person here, man.
Calm
it doesn't
down.
matter how loud you are.
Gain some self-awareness, man. Let Jeremy continue. Let Jeremy continue. You're about to be muted.
Kosho is here too and didn't say nothing?
Exactly.
Your father in private.
What on earth? Right, okay, so if this is what's going to happen, this is what's going to happen, Kosho. If they interrupt, if you got Boonan, you got Cypher,
talk about it in private, Chemo. Go ahead, Jeremy.
Then we're going to take Kosho's action.
Talk about it in private, Chemo.
Just let me go.
I'm telling you, don't fuck with me. Don't fuck with me right now, man.
Relax,
Talk about it in private. Let
Coach.
Jeremy continue.
All right, just let me go. Now, the fatal flaw was that in our natural observed phenomena, the effect, the dependent variable we're going to have, there was nothing happening. The egg was just sitting there in the water. There was nothing happening.
No, there was something happening.
You need some kind of. You need something to happen. The egg, nothing's happening. The egg is just sitting in the middle of the water.
That's something.
Where does it? Yeah, that's something.
Happening. No, you have no movement.
So
Nothing's
what?
moving or anything.
An egg would not normally float in midair, would it?
How do you have an effect if there's no movement?
That's something.
Equilibrium is an effect.
You have no dependent variable. You have no effect. Nothing happening.
The egg is in starters. The egg is in equilibrium. That is an effect. It's an effect.
So you think an egg just sitting? Oh, all right. You think an egg just sitting there doing nothing is an effect?
Yes.
That's incorrect. You're wrong.
It's an effect because it's in equilibrium, which means the forces acting on it are perfectly counter to each other. Right?
You have nothing happening.
Are you still here? I mean, Jay, I don't know if you want to carry on with this nonsense or not. It's up to you. You get some real science, real understanding.
Go ahead.
So equilibrium simply means.
Yeah, I'm still here.
Equilibrium simply means that the forces acting on an object are equal, and therefore it doesn't move. It doesn't mean there's no forces acting on it, and so equilibrium is the effect of equal counterbalancing forces.
Normally, something would either float on the surface or sink directly to the bottom. So the fact that it's floating in the middle of the water is, in fact, quite marvelous and is a phenomenon, right? Your everyday phenomenon is, something either sinks or it floats. So to be in buoyant equilibrium in the middle of the water is quite incredible.
Yes. And so then I had my independent variable, which was the buoyant force, which I altered by changing the density or the weight of the fluid around it. Since I'm in the time of Archimedes, there's no Cavendish experiment. People don't have any theories of gravity, either Newton or Einstein. We just know that the buoyancy of an object is equal to the weight of the fluid it displaces. I change the weight of the fluid that is displaced, and I change the equilibrium of the egg, and it moves either up or down.
In a predictable fashion based on the buoyancy equation, and you can't do that with your stupid density disequilibrium bullshit. You cannot make a prediction about whether it's going to float or sink.
Do you want the definition of effect as a verb or a noun? Because either one of them, it totally annihilates everything you're saying about this being an effect.
This argument is not going to be one on dictionary definitions. It's one on
You're
on
saying you have an effect and you don't. So clearly now we need to go to the definition.
The egg is floating in the middle of the water. That's an effect. I just described that. That is an effect.
They're saying they have net zero force. Net zero force is what they're saying. But Brenda, when you add fresh water and the egg sinks, what force are you adding?
I'm not adding a force.
Correct.
That's we have movement.
That's how you know it's not a force. It's only density in the medium.
Brenda, are you saying that you've got acceleration then without a force?
No, I altered the buoyant force.
But there was an acceleration, right? You saw an acceleration, no?
Yeah, it moves towards the bottom of the glass.
There was an acceleration. What caused that acceleration?
My changing the buoyant force.
So buoyancy
change of force. You only added a different medium.
No, I changed since this is Archimedes' principle. The buoyant force is equal to the weight of the fluid. I changed the weight of the fluid.
So you're repeating that over and over again.
Yes, because you don't understand it.
When you added, when you added the fresh water, what force did you add to create the downward acceleration, which requires a force in your model? Go.
I didn't add. How do you add a force? I didn't add a force.
You don't. That's how we're destroying your argument.
She just twisted herself. She just dumped herself.
We just destroyed your argument, Brenda.
Ask backwards as usual.
Brenda has destroyed herself. She said, I added water, the egg fell, but there was no force.
We're counting what was said properly.
Well done, Brenda.
He's confused. He's thoroughly confused.
I don't know how confused. She said she added fresh water, reduced the buoyancy, and the egg will go in a downward motion. That's an acceleration.
There was an acceleration, but no force.
Curved. Since you addressed me curved, is that an acceleration going down? Motion? I assume you're going to be quiet now. So when she
don't assume over me while I'm talking then, faggot.
Oh, maybe I didn't hear. Your mic is terrible.
Well,
again.
maybe you should shut the fuck up once in a while when people are talking.
Yeah, just take it easy, man. Maybe just answer. Is it a force?
I did answer. I asked you a question.
Well, you broke up. Your mic is terrible. Your mic is crap, man.
Then don't address me, bitch.
So Rakia. So Rakia,
you talking to Brenda or me? Were you talking to Brenda or me? Because your mic is terrible.
I'm talking to you, faggot.
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 Well, are you talking to Brenda or me? I can't hear you.
Yeah,
You're using bitch and faggot. That doesn't adjust.
Yeah, because I'm talking to you.
Curved is obnoxious. He should be booted. So
Brenda hasn't done anything to you, so I don't know why you're starting this shit.
I'm not starting anything. I think.
Yeah, you were. You were.
I think Curved is calling me a faggot or Brenda a faggot.
But then you turned it. Then you turned it. You knew he was talking to you, and then you tried to talk about Brenda. Don't do that.
It's very unclear who he's talking to because I can't hear a word he's saying. I just hear faggot.
I could tell.
Bitch.
Okay, well, Curved. I really wish you would.
Do you want to talk about a downward force?
I really wish you wouldn't use that kind of language.
Do you want to talk about a downward force? Or you want to talk about personal stuff like Curve does?
I'm just watching the shit show, man.
I don't. Then go on mute. Then go on mute.
My evidence
for
Brenda. My evidence for the Earth being round doesn't have anything to do with
Snack, your mic is super crackly. Snack.
Yeah, it's worse than Curves.
Right, yeah.
So Brenda, is it a force or not?
The buoyant force is a force, yes.
No, the downward motion of the egg when you add the fresh water.
That was caused by the independent variable, which is the buoyant force.
You can't cause anything by you're adding fresh water, correct?
Yeah.
Yeah. So what is that?
It's water.
That's all you've done.
Yeah. Is that right?
Notice that no one's helping Brenda with this.
I'm just waiting for Brenda to.
I don't need any help. But
I'm sure it doesn't need any help. But she's reduced. The buoyant force is reduced, which means the balancing gravity. Previously, the forces were balanced. You reduce one force, the other force then takes over. It's not fucking rocket science, Jesus.
So there was an acceleration. What was that? Why did
there was an acceleration? Yes.
Why did it accelerate?
People for laughing and doesn't keep it.
Why did it accelerate?
I also think
she added fresh water. It started to accelerate. So was the cause of the acceleration her adding the fresh water?
I think
the cause is the buoyant.
T-Guy, hold on, Brenda. We're talking about your experiment. Can we talk about it? I'm saying to T-Guy, does he agree with you or not? So I just want to try and find out. Does he agree that when you added fresh water, the egg started to go down? Did that cause the acceleration or not?
Science doesn't really deal with this obsession about cause. We just describe a system, we manipulate it, we see what happens, and we make predictions. This idea of cause.
That's fine, but I want to. We see the egg go down. Why did it go down, T-Guy? Well, how? How did that happen? Do you care?
Fuck. Physics. Things will be stationary when there's no net force, and when there's a net force, then they accelerate. You change the net force. You've added it, so there's now a net force that's going to accelerate. I mean, are you seriously asking this question? Are you so stupid?
If she didn't add the fresh water, would it have gone down?
Hey, Chemo, babe, come on, talk to me, Chemo, babe.
Well, I want to talk about your experiment. You give your answer. You said it's
really
buoyancy.
Simple. I don't know.
Fresh water. What more do you need to say about your hypothesis?
Chemo. In my experiment, I don't need to know what gravity is, which is what you people are trying to see.
I didn't say gravity. I'm asking T-Guy that when you added the water, was that the cause of the egg going down?
No.
That's what I'm asking T-Guy.
No, it's not.
Where did the acceleration come from?
It comes from the buoyant force.
So you added buoyancy.
No, I didn't add. No, that's a reification error. That's actually a proper use of it. Nathan doesn't know fuck all about reification. I changed the weight of the fluid since the weight of since the buoyant force on an object is proportional to the weight of the fluid is displaced and the volume of the fluid, right? It's a proportional relationship. So I can change one. I could have changed the volume of the fluid, but I chose not to do that. I changed the independent variable. I altered the buoyant force. Because the buoyant force is a relation. The buoyant force is a relation. It's a proportional relation between the weight of the fluid displaced and its the volume of the fluid, the local acceleration of gravity. But I don't know about gravity yet. I'm living in Archimedes' time. I don't know about gravity. I just know that if I alter the weight of fluid surrounding an object, I can move it up or down in a column of water. That's all I need to know. That's all I know, and that's all I need to know. And I can determine the cause is the buoyant force.
So, T-Guy, the egg was in the middle of the cup, floating. We added water, fresh water. The egg starts to move.
Right, by adding water.
Brenda, yes. Hold on. I'm asking T-Guy, scientist.
Why can't Brenda answer? I mean, she's describing this.
Because
why do you want me to answer? I mean,
because you're a scientist, right? You said.
I'm a geneticist, so I'm not really an expert on floating eggs. So I'm not much more of a scientist than
I don't mind
on this.
Yeah, I don't mind.
Oh, you know that. Oh, that's fine.
Chemo.
You're an expert in this. That's all.
Chemo.
Not much more of a scientist than Brenda. Brenda, what are your credentials?
Oh, I graduated from high school.
Okay.
You don't need much more than that to defeat flat Earth. So,
Gotcha. Yeah. No, we're not talking about flat Earth. We're talking about an egg. We're talking about buoyancy and downward forces, aren't we? Who brought up flat Earth?
Well, you don't.
It sounds stupid, man. Are you sure you're
buoyant? Because this is a the question was about what constitutes a good scientific experiment. I gave this as you weren't here, Rakia, but there was a dispute over what constitutes a good scientific experiment. And I gave this as an example of a good scientific experiment because I have an observed phenomenon, a hypothesis, and I manipulate the independent variable to determine the cause.
You don't have any of that.
Keep going. I'm liking what I hear. I like when you talk.
Yeah, that's it. I determined the cause.
There is no such thing as buoyancy or gravity. It's either in equilibrium or in disequilibrium. And you can't show that you can manipulate buoyancy or gravity with direction or show that is an actual thing.
That's you're just lying now, Chemo.
You've done the experiment and you've showed us by telling us what variables you manipulated.
Yes,
you
and changed. So I can manipulate. I can
fresh water, which changed the density of the medium, which caused the egg to fall. That's why the scientist T-Guy doesn't understand what to do, because to him he's like, well, I can't explain that. You need the scientist.
We all understand it. This is like high school. I have, of course, a bit more than high school understanding because I've had a lifetime of being interested in the sciences, so I know a bit more. But I wouldn't call myself having any kind of anything close to a bachelor's degree.
Yeah, you think a shoe is a phenomenon, so again,
no, but she's all right. We're
just like
Brenda,
the egg.
You're very bright. You're very bright on the mainstream terms. We're questioning the mainstream, right? So we're not questioning you.
So what's wrong with my experiment?
About the mainstream?
What's wrong with my experiment, Rakia?
Well, it seems to be density and medium based. You seem to be saying that a lot. I don't know why you even need gravity or buoyancy.
Yeah, because that's what the buoyant force is. The buoyant force is the weight of the fluid displaced by an object.
Yeah, they seem theoretical, though, if you don't mind me saying. Yeah, all those forces seem to be just kind of in theory.
No, they're real.
I think that's what we're questioning. Yeah, I understand that you think they're real, and I do too, I guess.
Can theoretical forces make a real object move?
No, but changing the density and the medium that object is in can.
Yeah, I changed the buoyant force. I changed it.
No, you changed the medium.
Yes, by changing the weight of the fluid displaced, I changed the buoyant
force. So
leave
out buoyancy, and just say I changed the medium.
No, but you just want me to have a different hypothesis. I have this hypothesis.
Yeah, I understand. I don't want you to do anything. I'm just saying that's where the discrepancy is.
Just leave out the engine and transmission, Brenda. You don't need those. Just concentrate on the ignition key in the back wheel.
Hey, Boomer,
I think I'm pretty well done
here. You can leave out
here.
all that shit in the middle, sure.
I think I'm done here, and other people can chime in, and maybe they can help convince Rakia that he's wrong.
Good job, Brenda. Convince me. I'm just commenting on your experiment. It's good.
No, you're not. You just wanted me to do a different experiment.
No, I'm saying what I feel. Like, it just seems like you're changing the medium.
Well, Rakia, do you know the buoyant force equation, just out of curiosity?
No, I know when I change the medium that something will react.
Okay, so the buoyant force equation has a predictive capability.
Unfortunately, I am pulling up to my pour, so I'm
okay. Well, just look up the buoyant force equation and ask yourself what that little g is.
Okay, I may have been wrong. There you
little
might have
g
a natural
invokes
phenomenon
gravity,
with the egg just floating there. You might have a natural phenomenon.
So, Jeremy, hold on.
Like a shoe.
So you jumped to a conclusion before actually looking into anything? This is so unlike a flat earther.
It is. I jumped the gun a little bit, but I'll concede on this. You might have a natural observed phenomenon.
Yeah, but what you're including...
hypothesis. Go ahead.
You're including gravity in this equal and opposite force. When something's just equalized, it's at rest. There are no forces acting on it. If you change the medium, then it will either rise or fall. It won't just fall.
Something that is suspended, something that is not either falling to the ground, something that is not falling to the ground. Let's just say that something that is not fully at rest, it's like something that is suspended in a fluid, is not at rest. It is not. There's different forces. It's just that the forces that are acting upon it are equalized. It's not at rest.
What forces are acting on it?
Well, you got the buoyant force, and then you got gravity.
Gravity in a buoyant. What are you talking about? It's at rest. It's not going anywhere.
It's not at rest because it's suspended in a fluid.
So I'll tell you why. For example, if you take a giant container ship, on the ocean, it has no weight. You can't weigh it.
I thought he said you take a giant shit. I thought he said you take a giant shit.
It absolutely has weight.
It has when it's on the water, you cannot weigh the boat.
It's neutrally buoyant, but that doesn't mean it doesn't have weight.
It means that it's weightless.
It's not weightless.
That is crazy.
Bruh.
I've never heard anything
when it's equalized, it is weightless. You cannot weigh it.
That's not true. That's not true. A ship is not weightless when it's floating in water.
Bruh.
No, it has weight, but you won't be able to weigh it when it's in equilibrium.
You just said it was weightless. So does it have weight or is it weightless? Which one?
So obviously it has to be pressing on a surface.
You said it has weight, but now you're saying it's weightless. So if a ship leaves dry dock, if a ship leaves dry dock, right?
Yeah.
And goes into the water, does it lose its mass? Yes or no?
No. I'm saying if you take that ship into space, it has no weight.
No. We're talking on the water.
Yeah, on the water.
So now, okay.
How are you going to weigh it?
You went from the ship does have weight to it doesn't have weight. Now, if we launch a giant cargo ship into space, that's going to mean what exactly?
What? Would it need a force to get it up there, yeah?
Why can't you answer my very simple question? Does the ship have weight?
Because
yes
you
or
didn't
no?
answer my question. I said, how
you didn't answer my question first. Dude, you're not going to escape every single question that I asked.
I brought it up that if it has no... How are you going to weigh it in the ocean? You said, of course we can. I said, how? How are you weighing it when it's in the ocean?
I didn't say, of course we can. I said, of course it has weight.
Well, how did you weigh it?
I'm saying the mass didn't change, buddy.
But how did you weigh it when it was in the ocean?
I didn't weigh it when it's in the ocean.
Well, there you go. That's the point.
So
You
you're
don't
saying
have
that
to
it
weigh
doesn't
it to
have-
say that something has weight.
The reason why you didn't weigh it
hold
in the
on.
ocean is because you
Hold
can't
on.
weigh it in the
Hold on,
ocean.
1 second. So you're saying you don't have weight right now because you're not on a scale. You weigh nothing?
No, I'm saying that if I go...
No, answer the goddamn question, man.
Yeah, you're missing the point.
Oh,
That's why.
all right, here's the problem. You're saying that if it's not on a scale, it has no weight. My question to you is,
No, I didn't say any of
you're
that.
you're not standing on a scale, right? Like, I can't measure your weight without removing you from the landmass and applying you to another machine, right? I can't weigh you while you're standing on the dirt. I have to take you and put you onto a scale. But what you're basically saying is when you're not on the scale, you're weightless.
No, I'm saying when you're in equilibrium, you're weightless.
But you're not. Just because you're in equilibrium, we could take that ship apart.
Try and listen to what's being said.
We could take that.
On the ocean,
hang on, wait. We could take that ship apart and weigh each part of the ship. It doesn't have to be all at once, and then we could devise a way to take that ship apart.
On the ship, you can't.
You're just going to talk over me, Chemo?
Because you're not answering what I'm saying.
You don't have to be able to find a scale big enough to weigh a fucking cargo liner to say that cargo liner definitely isn't weightless.
You couldn't weigh a basketball either when it's on top of the ocean. But no matter what it is, when it's in equilibrium, you cannot weigh it. It has no weight.
Yes, you can. There is ways of doing it.
Fucking God. Chemo.
Well, go on, how do you weigh? All right, let's take a basketball on top of the ocean. How are you going to weigh the ball?
You pick it up with a fish scale type weight, and you can get the weight that way.
Oh, so you've taken it now out of equilibrium. Now it's in disequilibrium. Now you can weigh it. Of course you can.
Made up words again, Chemo. Disequilibrium's a political and economic term, and you know that.
So if there was a force, if there was a buoyancy force acting on the object, you would be able to weigh it because there is a force, and you can have the boat where it is because there's the force, and you can weigh through that force.
Weight? Okay, so let's look at the definition of weight. Weight is often expressed in the formula weight equals mass times gravity. Is this object still subject to gravity? Yes. Does this object still have mass? Yes. So therefore, this thing has weight.
Gravity is not a force.
It doesn't matter if gravity is a force or whatever you want to call it. Is it still subject to gravity? If the answer is yes, and this object still has a mass, then it definitely has weight.
No, it's not.
Prove it. Prove that it doesn't. All right, if you're gonna say no, it doesn't.
No, they just got
No, like I said, look, in all seriousness now, like I said, once it's in equilibrium...
In all seriousness, now that I've been BTFO'd, in all seriousness.
No, because you're being silly. We focused on the ball and the boat. It doesn't matter what the size of the object is. You have to take it out of equilibrium to give it the weight. Otherwise,
it's weightless. Okay. What you don't understand is equilibrium takes into account the mass of an object, right? For something to be into equilibrium, that means that the opposing force, right, has to equal the other force. That's how an equilibrium works, right? They end up equaling each other. They don't cancel each other and erase the mass of each other. That's where you're having your problem.
Well, you're having a problem.
Let me finish. Right? I know this is hard for you. Right? When an ocean liner goes into the ocean, right? Mm-hmm. The ocean is supporting the weight of the cruise liner, right? As the cruise liner is trying to push out the water, right? They form a buoyancy equilibrium. Right? Okay. That does not mean the mass of the cruise liner or the mass of the ocean are erased. It means they have formed a relationship with one another.
No, well, again, when the only time you're going to recognize the weight of that boat is when it starts to push off the water. That's how you can get your speed and determine how fast you're going, because it's telling you how much it's pushing off the surface. And once it's sat there in equilibrium, you're not going to go...
Yes, you can, because we can calculate the mass needed to reach equilibrium, which means that the mass...
Look, you look at this backwards here. What you need to do is try to figure out if you can weigh something once it's in equilibrium. And once it's out of equilibrium, well, yeah, of course you can, because it's not trying to find its rest. You know, like liquids and objects try to seek their equilibrium at rest. They're looking for their level. That goes with all things, everything. You and I, all objects are trying to find their level.
Is an object on a balance and equilibrium?
You're talking about something floating in water. The buoyant force itself is the measurement of the weight of the object.
Buoyancy is not a force, okay? Otherwise, you'd be able to weigh.
Sorry, but it is, Chemo.
Well, what can it do? How can it cause direction? How can
Put something in it, it pushes it back.
What do you mean?
Acceleration. Only works if there is gravity, and gravity is not a force.
And gravity is a force.
There you go. You see, invoking more magic. Reality.
I'm not invoking magic. You're denying reality. I'm not invoking magic, Chemo.
I'm not denying anything.
You're simply denying reality.
Look, are you going with Newton's gravity or Einsteinian gravity?
It's all the same gravity, Chemo.
All the same. Oh my gosh! You
exactly
see,
the same gravity.
This is the problem here. There's not all the same, is it?
All right, Chemo. Here's a great idea. Bill just said something in chat. Let's take a scale, right, and then a bucket. Fill the bucket with water, and then put a little miniature boat in there, right? We will observe that even though the boat is not moving or accelerating, it is floating in an equilibrium state. The whole mass of the system has increased, meaning that even though the boat is in equilibrium, it still has mass. And we can record this using a scale.
No. So you put the scale at the bottom of the ocean, stand on it, and see if you can weigh yourself. Exactly.
I hope you fall to the bottom of the ocean.
You can't. The scale will sit on the bottom of the ocean or the bottom of the swimming pool or whatever, and you won't be able to weigh yourself, right?
Not if the scale is designed to be as equally buoyant as the ship.
No, you just take a normal scale down, like what you've got on there.
Well, why can't we use a scale that's just as equally buoyant as a ship?
Because you say everything falls down, but that's not true.
Okay, but let's just say we designed we designed the scale to measure the weight of the ship in water, and we decided that in order for this to work, we have to make the scale as equally buoyant to sit in the exact same position in the water as the ship.
Yeah.
Then we could weigh that ship, couldn't we? Therefore, the ship's now weightless.
What are you saying? So let's look at this again. You've got a scale. You've got the ship. You're going to make the scale buoyant. So it sits under the ship is what you're saying, yeah?
I said we're going to make it as equally buoyant as the ship itself.
Yeah. So look, listen. So the scale that you stand on in the bathroom, you're going to put that underneath the ship.
No, we're not talking about that. The ship won't fit in my bathroom, will it?
No, it could be a toy boat. Any boat, anything that's in water.
Okay, so we'd have to design a scale that is equally buoyant.
Well, go on, I'm listening.
Equally buoyant as the ship.
I'm listening. Show me how you can get the scale to give you the weight of the boat.
Because they're both equally buoyant.
Well, go on. Show me how that's done.
Are you fucking kidding me?
No, show me what you're
talking
about.
When you're in air, listen, when you're in air, the things that you're in air with are equally buoyant, assuming that they have mass.
No, stop talking about assumptions and show me what you're talking. You've got the boat in the water. You're going to weigh it now. Give me the weight.
I guess it wouldn't be equally buoyant because hydrogen isn't equally buoyant. Regardless, right? So you can create something that is as equally buoyant as the ship. You tell me why it would be impossible to weigh something if I created a scale that was equally buoyant with the ship.
You could never do that. It's wishful thinking.
What do you mean? How can I never? What is magical about the ship that can't be replicated with a scale?
Because
now you want Chemo to show you how to do your hypothetical.
It's not. He's making a claim, so don't interrupt. Watch me school this guy.
No, you just asked him to do it for you.
So no. So tell me why you think that a scale that isn't equally buoyant with the ship can't be created.
Buoyant. You're saying attached to the ship.
Is that what equally buoyant means?
I'm asking, is that what you mean?
Is that what equally buoyant means? If that's not what equally buoyant means, then that's not what I'm saying.
I'm trying to visualize what mathematical construct you're coming up with. struggling. So either
it has a certain amount of displacement, right? It has chambers and pockets of air in it that give it a certain buoyancy.
Where is the scale?
We can apply the buoyant force equation. Hang on. We can apply the buoyant force equation to make predictions about the buoyancy of the ship, right?
I'm sure you can.
So if we take and plug those numbers in to create a scale that would be the same, have the same buoyant force,
a mathematical
we could definitely use that to weigh the ship, could we not?
Can't go wrong with the mathematical scale, then no, of course.
I mean, can you show me how it wouldn't work?
A real scale in the water. You're not going to weigh that object.
Why would you even need to make a scale?
Not in the water.
Are you prepared to make a ship?
Well, no, you just weigh. You just calculate how much water it's displacing. That's the weight of the ship.
You can actually measure this.
No, you can't do that in the oceans there, Lewis.
You can actually measure this, and it's actually a pretty accurate way of doing it. You can fill a bucket all the way up, or any kind of container all the way up to the brim with water, and then put an object in it that displaces some of that water, capture the water that escaped, weigh that, and that is exactly how much the object you put in there weighs.
For goodness
Let me
sakes,
point out the dishonesty that you're doing, right? So we pointed out how you can measure the weight of the ship. Hang on, here's where you're being dishonest. Then you say you can't do that in the ocean. But then you say you could do this with a toy boat. Well, why does it need to be done in the ocean? What makes the ocean different?
Because if you know the volume of the water and the displacement, of course you can work it out. But in the ocean, when it's in equilibrium, you can't do that.
It doesn't mean that it magically doesn't have weight.
You can't do it on dry land.
No, I'm saying that it will have weight.
I'm sorry, pal, but they don't make it out of bathroom scales that weigh a fucking oil.
Sorry, Blue.
Don't make a set of scales you can weigh an ocean liner on, buddy.
To weigh the boat, you would either have to take a crane and pull it up out of the water, and then hang it up.
That'll do that, and no single crane that'll do that with a boat like you're talking about.
Once that giant boat is in the water, and you didn't know already how much it weighed, you would never be able to weigh it ever.
Emo, here's the problem, right? Is that you're trying to protect your argument by just saying we can't do this in the ocean?
Then tell me how you're going to do it. I'm not. I'm asking you how. How are you going to weigh the boat? You don't know how much it weighs. How are you going to weigh it? It's in the water.
You can weigh it in dry dock. All right, in dry dock, we can perform the Archimedes experiment, and we can measure the amount of water displaced as we lower the ship into the dry dock.
Into the ocean. No,
into the dry dock.
Once it's in the ocean,
No. The container of the ocean is different to the container that is like a bath or a tub.
No, it's not.
How is it different?
Bullshit.
Because the container is ice. Right? It's ice. So when the water reaches the ice, what do you think happens?
Wait, what are you saying?
I thought you were going to say with no manipulation, but they could correlate the water displacement. They could do that.
Let's think about this for a minute. If a big giant wave was heading towards the ice wall, the giant wave would hit the wall, hit the land,
ice wall,
and then just freeze, right? But obviously,
okay, hold on. Prove the ice wall.
If you're in a bath and you make a wave, the wave hits the wall, comes back through the water, and back on the other wall. That doesn't happen in the ocean,
all right, Chemo, you have just made a claim. Please show.
Okay, we don't even have to do all this. Hang on, you guys are missing a key point. We don't build. You don't build scales. Hang on, you don't build scales to determine the displacement of a ship. So the way you measure displacement is by using draft marks or load lines. A merchant vessel has 3 matching sets, one each mark on the port and starboard sides, forward, midships, and astern. These marks allow a ship's displacement to be determined to an accuracy of 0.5%. A draft observed at each set of marks is averaged to find a mean draft. The ship's hydrostatic cables show the corresponding volume displaced. That's what they do. That's how they do it.
It's like you don't listen or something, right?
I just told you how they measure displacement in the ocean.
How?
Oh my God!
He just got done saying it's like you don't listen, and then He completely doesn't miss what I was saying about how you measure displacement in the ocean. It's
He's been doing
hilarious.
this for years. I'm curious why you
That's
don't.
fucking hilarious.
I have
It's
a
like
question.
you don't listen.